GCSE Physics Boosters, Newton's third law. It's not a very long video, but it's an important one. Newton's third law, what's that then? Now, the way that you usually see it in a physics textbook, every action there is an equal and opposite reaction. And you see there from Principia, this is what Newton actually wrote. To every action there is always opposed an equal reaction. Bit confusing really. What do you mean? Action, reaction? What are you on about? I prefer, now if an object A exerts a force on object B, then object B will exert an equal and opposite force on object A. So looking at the diagram, if you throw this ball, and look, I'll put you on a skateboard, if you chuck the ball with a force of 50 newtons, then while you are pushing the ball, it is pushing you with a force of 50 newtons in the opposite direction. If you use a force of 50 newtons when you are throwing the ball, then a force of 50 newtons will act on you in the opposite direction while you're throwing it. I mean, once you've thrown it, then you have no influence over it. Okay, but the ball goes that way and you will go in the opposite direction. Not as fast because your mass is a lot bigger than the ball, but the force is the same. Forces come in pairs. Forces always come in equal and opposite pairs. Look at these examples. Let's work our way through them. So top left, a jet. Now, how do jets work and rockets? They work by ejecting gases at a very high speed. So there's big forces pushing the gases out the back of the rocket, and then from Newton's third law, the plane is pushed in the opposite direction. And then in the top middle, a jet ski is exactly the same. What it does is it chucks water out the back very fast as possible, lots of water coming out the back. So force on the water, that way you get pushed forward, Newton's third law. Top right is a tennis racket and a ball, and they're exerting a force on each other in opposite directions, and you can see how they are deformed as a result while they are in contact with each other. Bottom left, forces always come in pairs. And it's not always obvious where the second force is. This apple is being pulled downwards by the earth. So the earth is being pulled upwards by the apple. Now the acceleration of the apple will be 9.8 meters per second squared downwards. The acceleration of the earth will be zilch, will be negligible, because its mass is bigger than that of the apple. Bottom middle, walking. How do you walk? Well, what you're actually doing is you're pushing the ground backwards. And if you push the ground backwards, then the ground pushes you forwards and you move forward. If you imagine trying to walk on a very, very slippy surface where there's no friction, then it's very hard to push the ground backwards and you don't really go anywhere. And then lastly, bottom right, firing a weapon. Okay, if you hold a rifle, if you don't hold it properly, then you're going to break your shoulder. Now, why? Well, there's a big force acting on the bullet. So there's a big force acting on the rifle. It's called a recoil. And if you're not holding that rifle nice and snug, then you're going to break your shoulder. And it's all about Newton's third law. Here's a little something to think about. There's Sandra Bullock again. The tether attaching this astronaut to her spaceship has been broken by some space debris. And her jetpack is out of fuel. She forgot to fill it up. And all the crewmates are all fast asleep and the radio's broken again. How might she get back to her spaceship before her oxygen runs out? Have a little think. I'll show you the answer in 3, 2, 1. Now, if she threw her jetpack in the opposite direction to her ship, then from Newton's third law, a force would act on her towards the spaceship, and she would drift towards the spaceship, hopefully before the oxygen runs out. If ever you get a question like this in an exam, make sure that you say from Newton's third law. That's giving a scientific answer.